Question 14, Part C. Carbon-14 is a radioactive substance that decays over time. The amount of carbon-14 present in a kangaroo bone is given by C of t equals AE to the power of KT, where A and K are constants and T is the number of years since the kangaroo died. Part 1. Show that C of t satisfies dC dt equals Kc. Starting with the function c equals ae to the power of kt, differentiating c with respect to t, we get dc dt is equal to k times ae to the power of kt. But ae to the power of kt is equal to c from this equation here. Therefore, dc dt is equal to kc as required. Now, an alternative solution would be to use separation of variables to solve the differential equation dc dt equals kc. So separating the variables, we get dc over c is equal to k times dt. Now dc over c can be written as 1 over c dc. Now integrating both sides with respect to their corresponding variables, we get the integral of 1 over c dc is equal to the integral of k dt, which equals ln of capital C is equal to kt plus c, where this c here is the constant of integration. Raising both sides of the equation to base e, we get e to the power of ln of c is equal to e to the power of kt plus the constant of integration c. Just take note that this c here is a capital C different to this c here. Now we can apply some index laws on the right hand side. E to the power of kt plus c can be written as e to the power of kt times e to the power of c. And e to the power of ln of c, there'll be some cancellation there, we get capital C is equal to e to the power of kt times e to the power of c. Now e to the power of c is a constant, and we can let capital A equal e to the power of c. Hence, capital C is equal to ae to the power of kt as required. Part 2. After 5,730 years, half of the original amount of carbon-14 is present. Show that the value of K, correct to two significant figures, is negative 0.00012. Capital A represents the original amount of carbon-14. Now at time t equals 5,730 years, A over 2 units of carbon-14 remains. Hence, we can form the equation A over 2 is equal to AE to the power of 5,730K. Now we can divide both sides by A, assuming A is not equal to 0 of course, and we get 1 over 2 is equal to E to the power of 5,730K. Taking the natural logarithm of both sides, we get ln of 1 over 2 is equal to 5,730k. Now to make k the subject, we divide both sides of this equation by 5,730. So we get k is equal to ln of 1 over 2 divided by 5,730, and that equals negative 0.0001296 and so on, which rounds to negative 0.00012, correct to two significant figures as required. Part 3. The amount of carbon-14 now present in a kangaroo bone is 90% of the original amount. Find the number of years since the kangaroo died. Give your answer correct to two significant figures. Solve for t the equation 0.9, which is 90% in decimal, equals e to the power of negative 0.00012t. Taking the natural logarithm of both sides, we get ln of 0.9 is equal to negative 0.00012t. Dividing both sides of the equation by the coefficient of t to make t the subject, we get t is equal to ln of 0.9 divided by negative 0.00012, and that equals 878.004 and so on, which rounds to 880, correct to two significant figures. Therefore, the kangaroo died around 880 years ago.